Hi, welcome to the first real lecture of the semester. This one is on Introduction to the Language of Statistics. So since this is our first lecture, let me tell you, in these videos, this is equivalent to the when you're sitting in class and I'm writing stuff on the board. This is the online version of that. So just like if you were in a real classroom, you want to sit there and take notes. The benefit of this, as opposed to the classroom, is that you can pause it, rewind it, and replay it if you need to. But you should pay very close attention to these and don't just watch them passively. Okay, so let's talk about the goal of this course. The goal of this course is to promote statistical thinking, literacy, and reasoning. They're all closely related. Basically, we want to get you thinking about the big picture. We want you thinking about statistics. We want you to be able to interpret results when you see them, whether they be in a graph or a calculation or some of the things we'll get to later in the course. And we want you to understand that a big part of statistics is communicating the results, both in writing and verbally and orally. I was always taught, you can do a very sophisticated statistical analysis, and it doesn't matter unless you can tell people what it means. And so that's what this course is about. One thing you don't see on this list here is hand calculations. And that's because that's not the main goal here. I don't care if you can do a lot of the things by hand. In fact, a lot of times most of the time, we'll bypass hand calculations and just do them on the computer, either in StatCrunch or in SPSS. We'll do hand calculations only as often as I think they help you understand what the concept is that we're getting at. So anytime that I ask you to do a hand calculation, that's why. Because I think when you go through it a few times, you'll understand what it's doing. This gets you to a point where, I know in 5 years you're not going to leave here and calculate a standard deviation or do a hypothesis test. But what I want you to be able to do is leave this course able to be an intelligent consumer of statistics, meaning you might not be the one generating them, but if you read them in a newspaper or in a journal article, you'll be able to think about it and have a good idea of what's going on. Also, that you're not intimidated by that when you leave this course. So, a lot of people get intimidated when they see statistics in something, but by the time you leave here, that's going to be very comfortable for you, I hope. All right, so we have to look at the definition of statistics. Statistics is not a bunch of facts and figures. It's a field of study that has to do with conducting studies, to where part of it is designing how we collect data, and then how we analyze the data once we get it. I used to tell people I majored in mathism with a concentration in statistics, and that seems to be kind of the consensus among a lot of statistics students. But I'll tell you that this course is different from probably some of the other math courses you've had before. It's more verbal, more concept oriented. It's not a lot of solving equations, so it's kind of more big picture. But there is some calculating as well. All right, so again, big picture here. In this course, we're looking at studying a population. So we're interested in studying all of something. That's the key word, all. We're interested in all the subjects of interest. That could be people, it could be animals, it could be objects, or it could be events. Within that population, we're looking at attributes called variables. And these are some examples. A population might consist of all elementary schools in the United States. And the variable that we might be looking at for that population is the number of employees who work at that elementary school. So each line of the data, each observation is an elementary school. Another example, a population might consist of every Facebook post on all of Facebook in a given month. And then for every Facebook post, we might be looking at whether the post is personal to what's going on in that person's life, or if it's general, if it's a joke or having to do with the weather or the political climate or something. Okay, so for that population, every row of data is going to be a Facebook post, and that's going to be a lot of them. Another one we might be looking at, this one is people, all inmates in North Carolina prisons. So every element in that population is a person who is in prison. And a variable we might want to look at for those people is the number of upper respiratory infections that person gets in a year. So we've talked about population. What happens if the population is too big to access, where it's not feasible, or it's too expensive, or maybe not even possible? What we do is we take a sample. A sample is just part of the population. And we hope that by studying what's in the sample, we can get some information about the population. And we do that all the time in our daily lives. You know, if you go to the cafeteria and you see the big bowl of soup, you can't see all the way to the bottom. What do? You take a sample by picking up the ladle and see what's in the ladle. And that gives you an idea of what's in the big vat of soup. Okay, so parameters in statistics are related to population and sample. A parameter is a numeric characteristic like a mean about the population, and a statistic is the same thing but for the sample. It helps people a lot of times to remember parameter is for the population, statistic is for the sample. So PPSS, parameter, population, statistic, sample. Statistics help us estimate parameters, and statistics and parameters occur in pairs. So here's our first example. X bar, this X with a bar on it, it's called X bar, is the symbol for the sample mean. And this lowercase Greek letter mu is the symbol for the population mean. Okay, so one thing I want to mention is that there are a lot of symbols in this course, and that's unavoidable. And it's also very important that you know the symbols. That's why I brought this one up now, the X bar and mu. Later on in the course, you'll need to be able to read a problem and pick out, they'll say the sample mean is this, and you'll need to know to plug that in for X bar in the problem. So I'll ask you about the symbols a lot, probably every week in some of the MyStatLab questions. So write that down, start memorizing that, the earlier the better. So X bar would be the sample mean, and that is a statistic because that's for the sample. Mu is the population mean, and that's going to be a parameter because it's for the population. So, for example, we talked about North Carolina prison inmates. Suppose we want to estimate the mean number of times per year they get upper respiratory infections. They tend to get a lot because prisons are drafty, and that's an area of concern for lawmakers and prison officials. So one thing we might do, if there's too many prison inmates to see the entire population, we might take a sample of 1,000 inmates and see how many colds they get per year. So if we find the sample mean is 5.2 times per year, then it's a reasonable estimate to think that the population mean is about 5.2 colds per year. This is a statistical inference. We have inferred from the sample to the population. So if the sample mean is about 5.2, we think the population mean is probably pretty close to that. So again, that's statistical inference. Statistical inference is actually the basis for an entire branch of statistics, and we'll spend the second half of the course on this. It's actually, I don't want to say most, but probably most of what the field of statistics is all about. So we've gotten through some of the terms. Let's look at what the 3 units are of the course. The first unit is descriptive statistics. In that one, we'll look at graphical methods. We'll look at measures of center, like the mean. We'll look at measures of spread, how far apart the data is, or are they all spread out, or are they pretty close together? And we'll look at distribution. We'll look at outliers, things like that. So that's descriptive statistics. That's the first thing we'll do. After that, then we kind of take a little detour and do probability distributions. We need some tools from probability before we can do inferential statistics in the second half of the course. The probability makes up lays some of the groundwork for what we need for the inferential methods. So now we need to look at different kinds of data. The reason we care about what kind of data we're looking at is that it makes a difference what types of statistical methods we use. So different types of data require different statistical methods. So here we've got a variable. So for any variable, it could be either qualitative or quantitative. Now, qualitative data is categorical data. All right, so qualitative means qualities, so categories. And then quantitative is quantities, that's numeric. Within that, we've got these 4 levels of data, and we'll get more into that in just a second. So there's nominal level data, and that's qualitative. So actually nominal is a synonym for qualitative, categorical. We use those interchangeably. But then within quantitative data, we could be looking at ordinal level data, interval level data, or ratio level data. So, like we said, qualitative data is categorical. Here are some examples. A person's major, okay? Major is a category. Psychology, math, business, sociology, nursing, you name it. Those are all majors, and those are categories. The continent on which a city is located, Asia, Africa, etc. Beware though, because sometimes things might look numeric when they're actually categorical. So like number 3 here, a person's political party affiliation. We'll see this a lot in SPSS, Most of the time, if you've got something like Democrat, Republican, something that's categorical, they'll put numeric codes on it because SPSS needs the codes rather than the words to do some of the calculations. So even though this one is coded ones, twos, and threes, it's still qualitative data. All right, so it doesn't make sense to average those together. Next, a person's driver's license number. Those are numbers, but they really represent labels. So again, it doesn't make sense to average those together. So it's got to be qualitative. Finally, here we've got ages. And if we left off the options, ages by itself would be numeric. However, putting the options in here makes it categorical. Okay, we can't average these together. All right, so that's qualitative data. Quantitative data, we said, was numeric. Let's look at the first kind of quantitative data. The first is ordinal level data, and some books actually consider ordinal data to be qualitative, but it doesn't matter. Ordinal level data is usually something like first, second, third. So something like class rank. It also could be something like educational attainment, where they're sort of categorical, but really this first one is lower than number 2, which is lower than 3, which is lower than 4. So you could consider that to be ordinal level data. If you're ever doing an analysis and you come across ordinal level data, shiver in fear because it's pain. Try to avoid collecting, if you're doing a survey or something, try to avoid ordinal data. It's hard to work with. The second type of data is interval level data. This is numeric data where it makes sense to talk about the differences, but it doesn't make sense to talk about the ratios. So something like IQ. A difference of 10 points in IQ is the difference between 100 and 110 is about the same as the difference between 110 and 120 in terms of your intelligence. There's about that much difference. But there's not a 0 IQ. And it doesn't make sense to talk about ratios. Somebody with an IQ of 175, are they twice as smart as, did I say 175? I meant 150. Somebody with an IQ of 150 is not twice as smart as somebody with an IQ of 75. The ratios just don't work that way. But it does make sense to talk about a difference of 10 IQ points. Another one is temperature. If you're looking at it in Fahrenheit or Celsius, you could talk about a difference of, 2 degrees, and that makes sense. But it doesn't make sense to talk about the temperature today is 60, whereas it was 30 yesterday, so it's twice as hot. Okay, so ratios don't make sense. With these, there is a value of 0, but it doesn't represent nothing of something. Okay, so a temperature of 0 degrees Fahrenheit doesn't mean that there's no temperature. Okay, that's just where they decided to put the 0. Okay, If you're astute, you might be thinking, well, why didn't they say Kelvin? Kelvin actually has a natural zero, but don't worry about that. Now let's talk about ratio data. Ratio data is numeric data, but there is a natural zero, and it does make sense to talk about ratios. So the number of questions somebody answered correctly on a test. If the value is 0, that actually means that they got no questions correct. And if somebody got, I don't know, say 10 questions correct, it does make sense to talk about that being twice as many as making 5 questions correct. And the same thing is true with things like distance and time. You could talk about I ran twice as far yesterday as I did today. And those ratios make sense. And the same thing with time. It took me twice as long to drive to work yesterday as it did today. Those ratios make sense. So that's ratio level data. There's one other kind of data I want to mention. It comes up a lot in surveys. You've seen these questions where the possible responses are strongly agree, neither agree nor disagree, etc. That's called Likert data. Likert data is ordinal data, but a lot of times they treat it as interval, and they actually will sometimes average that together. It's not ideal, but they do it. So that's ordinal data. All right. So that's it for the first lesson. Keep working through these. I'll always post the PowerPoints with the videos, so you have access to that. And as always, let me know if you have any questions.